All right, so this is Pre-Calculus 20, and this is section 9.2, part 2. So we have a little bit to clean up from a continuation of what we did yesterday. So yesterday, as you recall, just a bit of a review here, we talked about these inequalities with only one variable, like the x, right? We're looking for values for x that make the inequalities true. And so we're just talking about values on the x-axis, so x values only. We're not talking about points or regions that we shade or anything, it's just x values. So we went over that a little bit yesterday. From the graph, it's easy to tell where y is positive and where y is negative. So again, that was yesterday's lesson. Thank you. Today, I want to go over just this little part right here, method 2, roots and test points. Okay? So you do not need to graph the whole thing in order to see the solutions. You don't have to. You can just go straight from the inequality. So let's just say, can someone grab that door, please? Carson, can you grab that door? Let's say we have something like this. And I want to find out where this is greater than or equal to 0. Okay? So let's say this is the inequality. Again, from part 1, you can graph and look at the graph. But what you can do now is understand that, hey, if this is a parabola that has some x-intercepts somewhere, right, if it looks something like this, then we can find this algebraically from just the expression here, right? And that we'll be able to factor it and find solutions to the equation. Okay, so again, what you want to do is you want to take this expression, let it equal 0 to solve for the roots. So you would factor x plus 1 times x minus 3, and then find out where that equals 0 to find out where the roots are. And here, this is what you have. So again, factor, zero product principle, find out where the x-intercepts are, the roots. And then again, you still don't have to graph it. What you see is that this is where the graph is going to touch the x-axis. And in this case, because there's two of them, you know it's going to cross the x-axis there. So here's -1 and here's 3. Because this is a parabola that opens upward because it has a positive a value, you know that it's going to look something like this. This is going to be a cross right here. It's going to come down. It's going to go back up. You don't know exactly where it goes to here, where it crosses the y. It doesn't matter right now. Well, you do know where it crosses the y, but you just have an idea that this is an intercept and this is an intercept. So even from that, you can envision this and you know where it's positive or negative. But if it's a little tricky, or if we have 3 intercepts, like if it's a crazy graph and it crosses more than 2 times, then what you could do is just use test points. So there's this part right here, test points. So in between -1 and 3, you can find out if the graph is positive or negative. And it's really easy. You just pick a point for x that's in between the roots. So like x equals 0 is in there. And so if you plug in x equals 0, right, then you can evaluate what you get there. So let me take the x's out. We'll put a 0 there and a times 0 there. And then we get 0 minus 3 is greater than 0. So is that true? Is -3 greater than 0? No, it's not true. So this in between is not part of the solution in between. Okay, see that? You can just take a test point and just see. So what about if we tried something beyond 3, like over here, 4, 5, or 6? You do the same thing, and this can be really quick. Just pick 4 maybe, and see what the sign is there. So that's 16 minus 8 minus 3. So that's 16 minus 11 is 5. Is 5 greater than or equal to 0? Yes. So this, anything greater than 3, and because it could be or equal to, it's actually x greater than or equal to 3 is part of our solution set. And that's all from test points. It's not from a graph. So you don't actually need the graph. And then, of course, you would want to test a value over here to see if that makes sense as well. So let's just do that because you might not believe me if I say it does. So -2, let's say, -2. That's going to be 4 plus 4 minus 3. Is that greater than or equal to 0? That's 8. That's 5. See that? So that is true as well. So that means that a point here in this region is also good. So you would just simply put a comma. You could put a comma, that's totally fine. And then say x also less than or equal to -1. And that's one way you could just list the solutions there, okay? So again, that is not looking at a graph. That is just using the roots and test points, okay? This whole idea of roots and test points are going to be very, very important when we get into pre-calculus and calculus. And I won't talk too much about it right now, but we're going to do something, and you tell me if you've ever heard of this before, if we've done this. I don't think we have. But have we ever done something called sign analysis? Probably not. So anyways, I won't talk too much about it. But in pre-calculus 30, and calculus, of course, we'll be doing sign analysis, which is in essence this right here. It's something just like this. You find the roots and you find out where it's positive, where it's negative, and you do that for every factor, and then you can find out where the function is either positive or negative. It's just for more complicated ones. All right. So that's the little mini lesson on part 2. I think we've really covered everything other than that. So again, here's the key ideas, and you've done part number 1 and number 2 already. I'm going to do an example with you from the text just so we can make sure we're on the same page with this. Okay. So let's do number 4a together, and that will be part of your assignment. So let's see, I'll give you 3a, 4ac. Oh, you know what? They do actually talk about sign analysis here, but I think that's just with this test point. They also talk about case analysis. And so again, that's just basically the test point. You can draw a number line and find out where the x values make it positive or negative. So you'll have to look at that wording there. I can help you with that later if you need it. So all right, so here's your assignment. We'll do 4a with you. So 4a says this: use roots and test points to determine the solution to each inequality. So we have already this expression factored already. And so what we're going to do is we're going to find out where the roots are. So obviously the roots are at x equals 0 and at x equals -6. Is that true? Well, this is actually not 0, is it? Okay, so let's just pay close attention to this. This has to be 0 in order for these to be roots. Remember that? Because really what we're doing is we're looking at this equals 0. So these are not the roots, because that's not a 0 over here. That's a 40. Okay, so use roots and test points. So what you can do here is let's expand this out and get an equation equaling 0 to find the actual roots. So for this one, you want to go x squared plus 6x minus 40, because I'm going to get this 40 over here as well. And I'm going to make this equal to an equation. Okay. Now, can we factor this? Can we factor this into two binomials? What are two numbers that multiply to 40 and have a difference of 6? 10 and 4. Very good. So x times x is going to give us x squared. And again, we need two numbers that multiply to -40 that add up to also give us 6. So that looks like a positive 10 and a -4. That would multiply to -40. And those two terms would also add to 6. Okay, so now we're looking good here. So the roots are x equals -10. That's what makes this factor 0. And x equals positive 4. That's what makes this factor equal 0. So one or both of them have to equal 0 in order for this equation to equal 0. Okay, so if you want to put those on a number line, I would encourage you to do that. You don't have to, but it shows you visually a little bit what you're looking at. So now we want to try points over here, in here, and over here to see if we have those areas or those sections of the domain, the x values, which are the solutions to the ones we're looking for. So what we're really doing here is we're actually, because I moved this all around, this is actually x squared plus 6x minus 40 is greater than or equal to 0, right? Because remember, this was the sign. So I'm looking for where it's 0 or positive. 0 or positive. That's what we're looking for. So a test point, real quick. Let's take 0. Zero's over here, I guess. Wait, what? What did I just do there? Oh, that's negative 10. Sorry. Negative 10. So 0 is right here. So negative 10. That's negative 10 and 4. I forgot the negative. So 0. What does 0 give us? Well, 0 plus 0 minus 40. Is that greater than 0? Negative 40 greater than 0? Nope. So this is makes it negative here, right? It's less than, whatever. So this is not part of the solution set. If you think about this graphically as a parabola, if this is not part of the solution set, chances are that these ones are. So you probably know that now. So let's do a quick check to see. So let's pick 5 maybe. 5 is over here. And so 5 squared plus 6 times 5 minus 40, is that greater than or equal to 0? 25 plus 30 minus 40, what's that? That's 55 minus 40 is 15. So 15 greater than or equal to 0? Yes. So that one's good. And you can do the same for a value that's less than negative 10, like negative 20. You could plug that in and see if that makes the inequality true. And I think you would find that that does as well. So the solution set would be solution set equals, use your braces, don't use brackets, not regular brackets. You have to use these braces, these funny brackets, okay? And you'd have to express the part of the domain that's less than or equal to negative 10. So that's x less than or equal to negative 10. That's what makes this true. And also greater than or equal to 4. X is greater than or equal to positive 4. Okay? Right? So that does, it seems like a lot of work for one question. I'm not giving you a whole ton of questions in your homework, but I'm of course taking my time at every step, hopefully to try and pull you along here. So this is not going to take you this long, these questions, but as long as you have this idea, it'll be a little slow at the beginning, but the more you do, the more practice, the quicker it'll be. So of course, is someone checking this solution? Does this agree with the back of the book there at all? Hopefully. Okay, so the question was asked here, is this okay to write this solution like this? Which, if you read it carefully, it seems like, hey, x is greater than or less than negative 10, and x is greater than 4. So that does technically say that there's two separate parts of the domain that are not continuously attached. But generally, because this is often can be confused with the other way where there's expressing one continuous, this is not usually used. We don't usually write it like this. So please separate it. If it's not one continuous part of the domain, if it's two separate parts, write them separately. Okay? So yeah, just write them separately. Okay? Yeah, I think that's the convention. That's the common convention. Okay. All right. So that's test points, and maybe I'll just show you an example on sign analysis here real quick as well, because we have a few minutes. So I'll put that on the next video though. Okay, so sign analysis. Let's just take a few minutes on sign analysis here, and I want to show you what it looks like, because the textbook does refer to it, and there is a small section in this chapter where you're introduced to it. So I'll do it for the first time here with you. So what you want to do for sign analysis is keep in mind that we are looking for an inequality, so solution set including x values. And you do have to factor, okay? So the key to this is factoring. So again, x plus 10, x minus 4 is how this is factored. This is the same question that we just got finished doing. Now sign analysis is actually set up different ways in different textbooks and things like that. I'll show you how I do it in my classes, so you'll see this again in Pre-Calculus 30 if you're with me, and in Calculus 30 AP, 30L, all the calculus stuff. If you're with me, this is the way I do it. The textbook might lay it out just a little differently, so I'll show you how I do it. Really easy. A big long L, okay? This bottom part is technically the number line right here. This bottom part of this is the number line. So I'll show you that in a second. That's number line right here. And what you do is you put your factors on the side here. Okay? And again, this actually really comes into, it helps a lot when there's more than two factors, because you're going to have big polynomials you're going to have to deal with 3, 4 factors. And so this is where sign analysis really helps. But I'll use a simple example to show you how it works first. So what we do is we find the roots now, and we put them in sort of like rows here. Okay, so there's like 2 rows here, right? So x plus 10, where is that 0? At x equals what? X minus 10 equal to 0 when x is? Negative 10. So somewhere on your number line over here, we're going to put negative 10. And in this row across from this factor, we're going to put a 0. So what this says is that this factor, x plus 10, equals 0 at x equals negative 10. See that? That kind of lines up. Now what you do is you actually use the signs plus or minus, positive or negative, to show where this factor is positive or negative. So for example, if I have a value that's greater than negative 10, like 0, what does this factor become? Positive or negative? So in this region over here, when this is, let's say, 0 is right here, okay, there's 0. If I choose 0, 0 plus 10, is that positive or negative? 0 plus 10 is positive 10, right? So that means that everything on this side of 0, or sorry, on this side of negative 10 will make this factor positive. And so that's what you do. You put a whole bunch of positives in that row on the right side of this 0. So it's like we're doing test points, right? It's very similar. Now on the left side of where this root would be, where this is 0, you pick another value, let's say like minus 20 or something, right? Just for an example, random. Negative 20 plus 10 is negative 10. So that's a negative value. So you would put negative signs to the left here. So again, what we're doing is this is like a number line down here. And at negative 10, this is where this factor is equal to 0. And then over here on the number line, it's positive always. And over here, it's negative. So we'll do the same thing for this one. The 0 is at positive 4 and positive 4. So we'll make sure the number line is in order. And we'll put a 0 right here above positive 4. And really quickly, we can test 0. 0 minus 4 is a negative. So that means on this side of that 0, this is all negative. And a number larger than 4, we could try 5. 5 minus 4 is a positive 1. So the values of this factor are all positive on that side. Okay? So it's kind of like we're doing multiple number lines. So that's the bulk of it. And now what we do is we can say this. Watch this. This is really cool. Well, teacher cool, right? But the function now, so I usually write f of x right here. And then in this little spot right here, I can show what this whole function is. The whole function is the product of these two. So guess what? Negative times negative. In this region over here, the function is positive. You see, because I have a negative times a negative. Right here at negative 10, it's 0 times a negative. Well, that's 0. So that's a root. And then over here, this whole region right here, that's positive, and this is negative. So what's a positive times negative? Negative. Here's a 0. Positive times 0 is 0. And then literally, I'm just looking down the column, positive times positive, that's positive. So this is a nice visual and actually makes it pretty easy for you to see now what the solutions are to this. So where is this expression that's made up of these factors, where is it positive or 0? Well, it's 0 here and positive over there. 0 here and positive over there. So now you can easily see that the solution set is everything that is less than or equal to, sorry, wrong one, less than or equal to negative 10, and where x is greater than or equal to positive 4. And that's the same thing that we came up with in the example just before that, doing it a little different way, right? So that's the same thing that we did using just kind of a number line and test points. But that's how you do it using sign analysis. Okay? So again, that's your first look at sign analysis. Hopefully that helps to kind of get you started on sign analysis and your initial understanding. And like I say, in pre-calculus 30 and in calculus, we'll use this a lot and you'll get really good at it. But that's kind of how sign analysis works. Any questions? No questions? All right. So, yeah, you guys can keep working on your assignment. And I did throw that assignment up on the board there before, so you can keep working on that. Here's a quick shot of your textbook, in case you get caught at home without your textbook. I mean, who goes home without their textbook, right? It never happens, but you know, I've heard that happens somewhere in the world.